Okay, next is addition of inert gas. So we have two conditions here. So either at constant volume or at constant pressure. Okay, so now we refer to the adding inert gas at constant volume. So when inert gas is added at constant volume, the total number of gases molecule will increase. Okay, total gas pressure container will increase, but partial pressure of each of the reactant gases does not change. So which means each of the partial pressure does not change. So only change the total pressure. Okay, so adding inert gas does not change the volume. Okay, does not change. Adding inert gas does not change the volume, so has no effect on the equilibrium position. So system will still at equilibrium where Q is equals to K. Alright, so all reactant and product concentration remain the same. Okay, remain the same. So this is the example, right? So before adding the inert gas, the total pressure here, we have partial pressure of A plus partial pressure of B. Okay, let's say the total pressure here is 10 atm. Okay, right. So and the size, okay, the size of the container remain the same, which means the volume of the container is remain the same, constant, which means constant. Right, so we add one more gas. Okay, that is referred to the helium gas here. Okay, here is the helium gas. We add the helium gas. Right, what would happen? Okay, so the total pressure here, it will increase. Okay, which means the partial pressure for A and B is remain the same before and after the addition of the inert gas at the constant volume. Okay, so because there is no changes in the partial pressure of A and B, so the direction of the equilibrium will remain the same, where the value of Q is equal to K, the system is still at equilibrium, no change. Alright, next, the second changes. Okay, if we adding inert gas at constant pressure, so what would happen? Total gas pressure remain unchanged. Remain unchanged. So why? Because constant pressure, so remain unchanged the total pressure, but partial pressure of the reactant gases decrease. Okay, decrease. Okay, so meaning that, let's say I have partial pressure A, it will decrease. Okay, partial pressure decrease. So therefore the volume will increase. So according to the Chatelier principle, adding inert gas at constant pressure, it will shift the equilibrium position to increase the number of mole. So meaning that each of the partial pressure decrease. So in order to increase, the partial pressure, partial pressure, it want to increase. So the direction of the equilibrium should shift to the side that is more number of mole. Okay, right. So therefore, system will shift to the most or larger number of mole of gases. Okay. Okay, let's say we take an example here, right? So before adding the inert gas, right, the total pressure is 10. Okay, after adding inert gas, which refer to the helium gas here, so the total, because the pressure is constant, okay, pressure constant, so total pressure remain the same. Okay, remain the same. Let's say the inert gas, the pressure of the inert gas is 2 atm. So therefore, the partial pressure for A and B will decrease in order to get the total pressure become 10, become constant. Alright, so because of that, the system try to increase the partial pressure of A and partial pressure of B. Okay, which means A increase by shift to the side that is greater number of mole. Okay, same thing goes to B lah. Increase. So shift the direction that has total number of mole lah. Okay.